Hi everyone, welcome to the video on mixtures. So if you've been following my series of videos, we've been doing lots of problems and things like that, but this series of videos is quite a few definitions, examples, things like that. So um, it's sort of dry, but we're just going to talk through it. I'm going to try to give you some pictures, some more examples, so that hopefully if you watch this and read, then these will stick with you. We discussed way back, quite a few videos ago, what a pure substance is versus a mixture. So pure substances are our elements and compounds. Okay, but most matter that we are in contact with is a mixture of two or more substances. So we have heterogeneous mixtures, and these mixtures do not have a uniform composition throughout the sample. So I think of this as they do not have, or they do have distinguishable parts. Something like, you think of vegetable soup, you can pick out the peas and the carrots and the potatoes. Okay, you can see the parts of it. A homogeneous mixture is uniform throughout, so it has a uniform composition throughout the sample, and you cannot pick apart the pieces. A solution is a type of homogeneous mixture, and it contains small particles. And liquid solutions, which is what we come across a lot in the lab, are transparent. Okay, so we can see through them. Solutions consist of two parts, and this is the sort of some new definitions here. So it consists of the solute and the solvent. Students will accidentally get this backwards, so be sure you go over and over this. The solute is the substance that is being dissolved. Okay, and it is in a lesser amount. The solvent is the substance present in the larger amount, and it's what's doing the dissolving. So if you think about sugar water, okay, so sugar is the solute, and then when you add water and you dissolve the sugar, the water is the solvent. And so water is kind of a universal solvent. And when you use water as a solvent, it's called an aqueous solution. So aqueous just means that it's in water. Okay, we are not limited to just liquid solutions. So we have gases. So two gases, a mixture. The air you breathe consists of nitrogen, mostly 78%, oxygen, water, CO2. Okay, it is a homogeneous mixture. So the air we breathe, it's gases, two or more gases. Okay, you can have a solid in a liquid. It can also be a solution. Okay, so just like the example I mentioned, sugar water. Here, your example here is salt water. Okay, and then you can also have a liquid in a solid. So here, the example is a dental filling. Okay, it's a liquid in the solid. So mercury is liquid, and then it's mixed in with the solid silver and in the teeth. Um, so we can have different ones. Of course, we can have liquids and liquids, so solutions. So if you mix water and an alcohol, for example, those will make a homogeneous mixture and be a liquid solution. Okay, there are other types of mixtures. So first one was our solutions, right? And this is when it's homogeneous and we have two parts, a solute and a solvent. Okay, colloids and suspensions. These are our other two types of mixtures. A colloid is a homogeneous mixture, so similar to a solution, but it has very large particles. Okay, for our solutions, remember these were smaller particles. Okay, colloids have larger particles and they often have an opaque appearance. And the best way that my students understand this is by being given examples. So examples of a colloid Our fog, smoke, paint, milk, mayonnaise has that sort of cloudy, a cloud is an example, appearance, shaving cream, but they don't separate. Okay, so the particles are kept together. Okay, they cannot be filtered from each other. Okay, same with our solution. Okay, and so they do not settle out. A suspension is heterogeneous, so that's the biggest difference here. So a colloid, okay, it stays together. Okay, stays in solution if you want to think of it that way, but it's not a solution. So it's a mixture with larger particles. A suspension is heterogeneous. This contains large particles that suspend in a liquid. Okay, particles are so large that they do not dissolve in a liquid. They can be filtered away from the liquid or separated using a centrifuge. Okay, so this suspension is much different than a colloid and a solution. Okay, in that the particles are very large, just like they are here, but they don't dissolve in each other. So this is like oil and water. If you put oil and water together, you get a suspension. So it's suspended out away from each other. And you see those two layers. Okay, so these are not soluble in each other. Okay, and so this is heterogeneous and a suspension. So if we want to compare all three, if you compare a solution to a colloid, a solution has small particle size. Okay, there's no settling, and you cannot be separated by filtration. Okay, a colloid has larger particle size, but it also has no settling and can typically not be filtered by common filtration techniques. A suspension has large particle size, but you do see settling. So we saw those two separate layers in the previous picture. And you can separate by filtration or centrifuge. You can also just decant or pour off. So if you look at that oil and water, you could pour off the oil and leave behind the water. All right, so I hope this helps, and I will see you next time.